Welcome back to the course Modeling Combustion with ANSYS Fluent offered by Adult Systems. So today we will discuss about overview of combustion. So starting the class, what is combustion? Combustion is nothing but a chemical reaction in which a substance reacts rapidly with oxygen and gives off heat. So the substance which reacts with oxygen is nothing but fuel. So this fuel may be present in any form, solid, liquid or gas. So combustion to happen, three ingredients are required: fuel, oxygen and a little bit of heat, which we call as ignition. So with these three ingredients we can have a combustion which will give products, which will give some exhaust and which will produce some heat. So this combustion can be used in various applications. So cooking, jet engines, internal combustion engines, these all are examples of combustion. So when it comes to modeling of combustion through CFD, it is very tactic and one should have enough good knowledge of principles in physics about combustion. So let's see classification of combustion. A general classification is given here with some of the categories. There may be more categories, but I have specified in these categories. So general, it have 5 classes of combustion which we have studied till now. Next, flame visibility, based on if the flame is visible or not, it has been classified. So smoldering is one of combustion where we cannot see the flame, but still the whole process is happening behind. Next is fuel oxidizer mixing, how both of them are mixed before the ignition process. Next is speed of propagation. So if the flame is propagating in subsonic speeds, we call it as deflagration. If it is propagating in supersonic speeds, that is above Mach 1, then it is called as detonation. Then it comes to Reynolds number. So based on Reynolds number, it may be laminar, it may be turbulent. Last one is completely application based. That is, engine is one of the application, and based on engine, we can classify combustion as internal diesel, HCCI or low temperature, and dilute gasoline. So these are some of the categories where we can classify combustion. So for this class we will be completely focusing on premixed and non-premixed combustion, because the CFD solver which we are dealing with, it has specific combustion models for these kind of combustion. So premixed and non-premixed combustion. In non-premixed combustion, the reactants enter the reaction zone in different streams. This combustion is also called as diffusion because molecular diffusion is involved for the mixing of fuel and oxidizer. So classic example of non-premixed combustion is the candle. So candle, it continuously consumes the wax as well as the air which is present around the wick. And if we look for advanced examples, then the gas turbine engines in our aircraft, they are very advanced level of non-premixed combustion. Now coming to premixed combustion, it is completely opposite of non-premixed, where the reactants are mixed thoroughly before they are ignited. So this kind of combustion is complex and has to be handled carefully. Basic example for premixed combustion which we have used in our chemistry lab, the burner which we have used, it is a very good example of premixed combustion where air and fuel are already mixed and are supplied through a tube to the mouth. And if we look for some advanced examples, then they are at automobiles which we have, they run on internal combustion engines. So what we studied for this class, combustion is a chemical process in which a substance, a fuel substance, reacts rapidly with oxygen and gives off heat. The substance is called fuel and the oxygen present is called as oxidizer. Then we have seen various applications of combustion, and CFD approach for combustion is tactic. Then classification of combustion we have seen with various categories, out of which non-premixed and premixed we are studying. So non-premixed is where the reactants, they enter the combustion zone or reaction zone separately, while premixed is kind of combustion where reactants are mixed thoroughly before they are ignited. So the references for this lecture are given below. So for the next class we will start with Introduction to ANSYS Fluent. Thank you.